Hi, today we are going to look at our second video on probability. We know that who was Rahul and what he wanted to do. He wanted to win the dice game every time, but when he went to the professor, he came to know about a lot of things in terms of probability and in terms of mathematics. So he he became interested in probability and he asked the professor to teach him the probability. Professor has taken first class and today is the second class of Rahul. So Rahul went to the professor and asked that, sir, today is the second class, have you forgot? The professor said, no, Rahul, I was just waiting for you. So Rahul said, so sir, what are the topics which we are going to cover up today? Because in first class we have looked at some small concept and we have done some small questions on that. Now, professor said, don't be silly, Rahul. Let's move to the class directly and start the class. Why to waste the time? So we are going to start the class. Before going to the probability, first you need to understand the concept of permutation and combination, because in the questions we will be looking at permutation and combinations concept, and to solve those questions you will have to have some knowledge about permutation and combination which you have already studied in class 11th. This is just a revision of that. If you know, then it's good. If you don't know, then revise it. There are some points I am covering up. Now first we will look at the permutation arrangement. Permutation, what is the permutation means? Permutation means is arrangement. Well, uh, I should not write the word permutation and arrangement. Permutation and arrangement is the same word. Okay, permutation means is arrangement. We are arranging the words. So the first point says that if you have a question that number of arrangement of n different object, then we will apply the formula of n factorial. For example, if four people are there and four chairs are there, so you someone is asking you that how many different ways are there in which you can arrange these four different member on four different chair. So what will you give the answer? 4 factorial. And how will you solve it? 4 into 3 into 2 into 1. From the number which is given like 5 or 4 factorial or 5 factorial, we will go till 1 and write multiplication in between those numbers. Now, number of arrangement of R objects are out of n different object. If if n objects are given and R objects are to be arranged in uh, in that manner, what would be the formula? We would be using the formula of NPR, n factorial divided by n minus r factorial. You will get this concept thoroughly when we will be doing questions on it. You just look at it on face. Now, total number of arrangement of word, if someone asks you that this is the word A, B, B, C, then how many number of ways are there in which you can arrange this word? So how will you solve this? These are alike objects or alike words, you can say, means where the repetition is happening. There we will use the word alike. So number of arrangement of n different object is n factorial. First what we will do is we will count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will write 9 factorial in the numerator. Now we will see what are the objects which are alike. So the alike objects are A, B, B, C, 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 C. So how many times A is getting repeated? 3 times. So we are dividing it by 3 factorial. How many times B is getting repeated? 2 times. So we are dividing it by 2 factorial. How many times C is getting repeated? 4 times. So we are going to divide it by 4 factorial. In this way, you can write it and you can get the formula. How will you solve this 9 factorial? 9 into 8 into 7 into 6 and followed by 1. Okay. Now, the total number of arrangement of word, if someone give you this word and ask you, then you will do in a similar way as we have done the previous question. There are total 15 elements or objects, you can say. We have taken the alphabets, so 15 alphabets, so 15 factorial divided by A is getting repeated by 4 times, B is getting repeated by 3 times, C is getting repeated no, so we will write 1 factorial. What is the meaning of 1 factorial? Means 1. 1 factorial means 1, and 0 factorial is also 1. DD is getting repeated by 2 times, E is getting repeated by 2 times, F is not getting repeated, 1 1 1. You can write it or you can not write it. You don't write it, there is no need, because the 1 factorial is 1, and we can solve it also. Now if uh, now combination means what? Selection. Here I have also write it uh, with the combination, but I should write it separately. Combination means is selection. We are selecting combination. In combination we are doing selection. So if you want to select R object from n different object, then the formula is n factorial upon R factorial into bracket n minus R factorial. It is similar to this permutation. Number of arrangement of R object out of, here we are doing arrangement and here you are selecting the objects. Are you getting my point? You are just dividing it by R factorial. In this formula, if you divide this formula just by R factorial, you will get the formula of combination. Here, where is the formula? There is the formula. R factorial, you have divided the R factorial. If you remove R factorial, it will become the formula of permutation. But here NCR, what is C? Combination. Here NPR, what is P? Permutation. Alright. So here if we want to do selection of alike object, how did we do permutation of this? 1, 2, 3, 4, 5. If someone asks you write the permutation of this word, how will you write? 5 factorial divided by A is getting repeated by 3 and B is getting repeated by 2. So 3 factorial into 2 factorial in denominator, and in numerator you will write 5 factorial. But if you want to select, there are two words, permutation and combination, arrangement or selection. Here we are doing selection. So how will you select? When we will be doing questions on it, questions on it, then you will be getting it very clearly. But right now you just understand it, try to understand it and try to remember the formulas. When we will be doing questions, you will understand the concept very clearly. Now uh, if you want to select the objects out of these 5 objects or 5 alphabets, I can say, then there are two cases possible. What are those two cases? Those two cases are either the alphabet can come same, the object can come same, or it can come different. Either you can get A, B, or you can get A, or you can get B, B. Uh, if you want to select two objects. All right. So if we are taking an example, that consider the objects. A, B, 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 C, C. These are 1, 2, 3, 4, 5, 6, 7 objects are there. So here 3 objects are there which are getting repeated. So how many cases would be formed here? 3 cases would be formed. First case is, in how many ways you can select one object? There are 3 ways: A, B or C. These This is getting repeated, that is why I have formed a block. I have formed a block on these alphabets, or on these objects we can say. So there are 3 ways to select one object. Either you can select A, or you can select B, or you can select C. I have formed block also. Second case, what is the second case? In how many ways we can select two objects? In how many ways you can select two objects? There may be two cases possible. Both are different, or both may be same. So these are the two cases which are possible. Now, third case is also there, that all three, how many ways we can select three objects, all the three objects. So here are also the three cases possible. All three you will get different. Either you get A, B or C. If you are selecting three objects, then you can get A, B, C. You can get B, B, B. You can get A, B, C. You can get C, B, A. Three objects are possible. Three alike objects. Alike objects means the repetition is happening. So here three alike objects are in only one block, which are B. B is getting repeated three times only. So three alike objects, if you are getting selected, if you are selecting the three alike object, then only one way is possible. That is, only B can come, because in A there are two, C there are two, but B is the only one which is getting repeated by three times. So three alike object is one way to select. One different object and two alike object. Here two alike, you alike means you can get C C, B B, A A, and we are talking about one different, then you can get A and you can get CC, you can get B, you can get AA, you can get C, you can get BB, C and BB. So one different and two are same, two are alike. So what is the combination we can make? One different, 3C1. How? 3 out of 3 you can get one different object, and if we want to get two alike object, then the possibility is 2C1. Alright, and all three, this is also a condition, that all three may be different. All three may be different. One, sorry, A, B and C you get. In this you will get all three is different, means 3C3. This is a very simple concept. C means combination, and you are selecting NCR. This is the formula, NCR. You are selecting. If we want to select R objects out of n different objects, then the formula is NCR. This is simply we have written here. You just need to understand the concept. You can write it very simply. Now, see the question. A bag contains 5 white balls, 7 black balls, and 4 red balls. Now, find the chance that 3 balls are drawn at random and all are white. How will we do this? How will we be doing this question? So the first thing is write the probability. What is the probability? Probability is number of favorable cases upon total number of cases. Here, what are the total number of cases? You can select white, sorry, you have white balls, you have black balls 7, you have 4 red balls. So 5 plus 7 plus 4, how much? 16. Out of 16, how many balls you want to select? out of 16 balls, how many balls you want to select? You want to select 3 balls. So 16C3, 16C3 is the total number of cases. Alright, and number of favorable cases would be uh, number of favorable cases would be, we have 5 white balls and the question is saying 3 balls are drawn, all right, but they all are white. So what are the white balls? Total number of white balls 5. out of 5 out of 5 only 3 can be selected because total number of white balls are 5 and 3 can be selected, so 5C3, simple. 5C3. Number of favorable cases is balls comes white, that is 5C3. Now the probability is, you can write, you can feed in this formula 5C3 in numerator upon denominator and you can solve it. 5C3 means NCR, formula is n factorial upon r factorial into bracket n minus r whole factorial. 3 boys, and this there is a next question. 3 boys and 3 girls are sitting in a row, means they are sitting one by one in a bench. Okay, we need to find the probability when 3 girls are sitting together. So what is the meaning of 3 girls are sitting together? Meaning is this: girl 1 is sitting there, girl 2 is sitting here, girl 3 is sitting here. Simply you can write the probability. What is probability? Favorable upon total. So here you are making a block. Here G1, G2 and G3, the mutation can be done in 3 factorial ways. G1, G2 and G3 can also get mutate. Means a girl 1 is there, girl 2 is there, girl 3 is there. But it is not a permanent, it is not a permanent thing that G1 will sit here, G2 will sit here and G3 will sit here. It is not permanent. G1 may sit here, G2 may sit here, G3 may sit here, G3 may sit also here, G3 may sit also here, girl 3 may also sit here, girl 2 may sit here, girl 2 may sit also here. It is not necessary that girl 2 will sit in between G1 and G3. So mutation can be done, and arrangement, we need to define the arrangement. So the number of possible arrangement of G1, G2 and G3, girl 1, girl 2 and girl 3 is 3 factorial. Number of see the definition: number of arrangement of n different objects. Now we come to the question: number of arrangement of n different objects. Number of arrangement of 3 different object is 3 factorial. Number of arrangement of n different object is n factorial. Have you got my point? So here they can also get mutate. G3 can sit in first position. It is not necessary that G3 will sit after G1 and G2. Alright? Same thing can happen with boys. So to arrange the boys, 3 factorial ways are there, but we have write 4 factorial. Why? Because specifically they are asking the possibility for girls, so we put the girls in a block. All right, the possibility for this block to mutate is 1 factorial also. Why? B1 is an object. Let us consider it as an object. It is an object, it is an object, it is an object, and it is also an object. Is it necessary that the girls will sit together after boys? No, the girls may sit together in between boys B2 and B3. The girls may sit together in between boys B1 and B2. The girl may sit together before B1. So it is not necessary that the block of girls means three girls will sit together in the last position. So this whole block is also getting permutated. So this will be also getting, we will also count this. All right. So the number of ways in which boys and girls can mutate are 4 factorial. So you will multiply the 3 factorial and 4 factorial because this is the total number of ways. All right. This is the total number of ways and total number of ways in which three girls can sit together. And the whole block you need to understand 1, 2, 3, 4, 5, 6. The total number of ways are 6 and the total number in which three girls are sitting together is 3 factorial into 4 factorial. 3 factorial into 4 factorial. Are you getting my point? And you can simply solve it. Second point is boys and girls are sitting alternatively. What is the meaning of alternative? Alternative means boy one, boy girl, or girl boy, girl boy. We will be finding out their arrangement one by one. First, we will find out the arrangement of this row. Then, we will find out the arrangement of next row. First, we will look at our first row. So, the possibility for girls is 3 factorial and the boys is also getting 3 factorial here because alternate solution they are asking, and here they were asking the solution for specific for girls. All right. Now, so this is 3 factorial into 3 factorial, and when the row is getting started by girl, then also 3 factorial into 3 factorial, you add these and divide it by the total number of ways, you will get the answer. Now we get into the different topic, that is, if E is an event, we have seen what is an event, that is a subset of sample space. All right. Now, and A be the number of favorable cases, B be the number of non-favorable cases. So the odds in favor of event E would be A ratio B, and odds against favor would be B ratio A. We will be getting, don't worry if you are not getting, no problem, but just try to remember this because we will be using it in questions, and when we will be doing this in question you will get a clear idea about what is it. All right, simple things are there. So here probability of event E would become A divided by A plus B, and probability of E complement would be B divided by A plus B. We would be getting it in the question. You just try to remember it just. Now, for example, the odds in favor of event E of an experiment when a dice is thrown, the occurrence of even prime number would be. What is the possibility of occurrence of prime number? 3. 1 by 3. What are the numbers? 2, 3 and 5. But what are the odd prime numbers? 3 and 5. Because 2 is even. 3 and 5 are the two odd prime numbers. So the occurrence would be 2. If you want to write the odds in favor, so you will write 2 ratio 4. If you want to write odd in favor of an experiment when a dice is thrown, then the occurrence of an even prime number would be 2 ratio 4. What is sample space? 1, 2, 3, 4, 5, 6, out of which 2 is our possibility, our probability. in which 3 comma 5 is coming, and 6 minus 2 is 4, that is rest of the outcomes. Are you getting the point? This is A and this is B. If you want to find the probability of E, then you can write A upon A plus B, 2 upon 2 plus 2 plus 4. So 2 upon 6 means 1 by 3. We have got the answer. Now, means this is just a concept. This is not a very important, but this is a concept which we need to which we need to remember. You just need to remember it whenever the questions will come. You need to understand that what is the odds in favor and what is the odds against favor. How you will write odds against favor? 4:2. Odds in favor is 2:4. So the odds against favor is 4:2. Now, what is the conditional probability? We will be looking at all these things, all these concepts in the questions. But first, you understand the concept. You remember it. What is it? The conditional probability says that it is a measure of probability of an event occurring given that another event has already occurred. Means probability of B by A, that is a notation of conditional probability, this slash. Wherever you will get this slash, you can know that this is conditional probability. So what is the meaning of probability of B by A? The meaning is conditional probability of an event B when event A has already happened. Conditional probability of an event B when an event A is already happened. Suppose you want to go from position point A to point B and from point B to point C. So to get to go to the point C, to reach the point C, first you need to go with the point B. All right, you cannot directly jump from A to C. First you need to go to B and then you will go to C. So the conditional probability is to reaching the point C is the probability of C when B is already happened, means when you have already reached at the point B. Okay, now let us look at the multiplication theorem. What is the multiplication theorem? Means it is denoted by A and B. Occurrence of both the events A and B. This is the sign of AND. Occurrence of both the event A and B. Mathematically, you can represent it. Occurrence of A and B. I have given you an example that if you want to go from point A to point C, you have to go through point B. You cannot directly jump to the point C. If you are in two dimension, alright, you cannot directly jump. You can go to A from A to B, then you can go from B to C. There is no direct way to go from A to C. Alright. So how you will get the probability that both the event has happened, the probability of A and B happened, the this look at the thing is equals to, I have right, the probability of A has happened and the probability of B when A has already happened, and the multiplication of that. Look at it again. How you can say that A and B both has happened? How can you say? You can say on the basis of this that probability of A, alright, and probability of B when A has already happened. So you are specifically telling that A has already happened, and probability of B you are writing. So A and B both are the two objects, and objects or events, and you are specifically telling that probability of event B when event A has already happened. So if event A has happened and you are getting and you are writing the probability is B, so A has already also happened and B has also happened. In this way, you can say A and B, probability of event A and B has or both have happened. And this is the multiplication theorem, that occurrence of both the events A and B. And we have got that occurrence of uh, in this example, you can see that probability of B when A has already happened. So if we are specifically telling that A has happened and B has already happened, because we are writing the probability of that. This is a multiplication theorem. From equation 1 you can derive the conditional probability, and from equation 2 also. This is the conditional probability. You can send this PA into the denominator and probability of B into the denominator in order to get conditional probability. Alright, now this is our last concept, which is independent and dependent event. If the occurrence or non-occurrence of an event will not affect the occurrence and non-occurrence of another event, then that event is known as independent event. Otherwise, we will say that dependent. Hope you got the point. If A and B, if mathematically, if we want to look at, if A and B both are independent events, then the probability of A when the probability of B has already happened would become probability of A. How? Because in multiplication theorem or in conditional probability, we used to say that probability of A when B has already happened, whereas when B has already occurred. But here A and B are independent, so the effect probability of A is not giving any effect to the probability of B. So you can simply write it probability of B, and here you can simply write it probability of A. And if you are writing the multiplication theorem, then probability of A and B is equals to probability of A and when probability of B when A has already happened. So here the effect of A on B is negligible. There is no effect because they are independent. So probability of B, how can you write probability of B simply normally? All right. So this is how you can get the probability of A and B when A and B both are independent. When both are dependent, then this the event B will give significant effect on event A, and event A will give significant effect on event B. Now we have taken two alphabets A and B. Here you can take three alphabets or three events, and if A, B, C are mutually independent, then A intersection B, A and B and C, the probability of that is PA, PB and PC. Here we have right probability of A and probability of B. So for today, that's all, and we will be looking at another things and the questions in class number 3.